Good morning. Let us see today determination of molar mass of polymers or macromolecules, DNA, protein, etc. There are four methods commonly used for the determination or measurement of molar mass of polymers. They are viscosity method, osmotic pressure method, light scattering method, and the fourth one is sedimentation method or ultracentrifuge method. Let us see viscosity method. This is also called viscometry. This method is based on the measurement of viscosity of polymer solution. This method is the simplest method, cheap, less expensive and widely used method for the determination of molar mass of polymers. Since absolute viscosity is difficult to measure, absolute viscosity of polymer is difficult to measure, there are four types of viscosities defined. There are four types of, how many types of viscosities? There are four types of viscosities because it is very difficult to measure the absolute viscosity of the polymer solution. First one is relative viscosity. What is relative viscosity? Specific viscosity, reduced viscosity and intrinsic viscosity. This intrinsic viscosity is related to the molar mass of the polymer solution. Okay. Now first, this intrinsic viscosity is derived from these three. Okay. Now let us first see, therefore it is very important to know what is the relative viscosity. Relative viscosity is represented by eta. Relative viscosity is equal to eta by eta naught, and eta equal to viscosity of the polymer solution and eta naught equal to viscosity of the pure solvent or reference liquid. How it is defined? It is defined that the relative viscosity of a polymer solution is defined as the ratio of viscosity of the polymer solution to viscosity of the pure solvent or water. Okay. On adding polymer or dissolving polymer in water, the viscosity increases or decreases. Okay. Therefore, the relative viscosity. Next, what is specific viscosity? It is very simple. Relative viscosity minus 1. Relative viscosity minus 1. Therefore, you substitute here, you will obtain eta minus eta naught divided by eta naught. Now, how it is defined in words? It is defined as the specific viscosity of a polymer solution is defined as the ratio of absolute viscosity of the polymer solution to the viscosity of the pure solvent. What is this term? This is the viscosity of the polymer solution. This is the viscosity of the liquid solvent. Therefore, it will give the absolute eta minus eta naught gives the absolute viscosity of the polymer. Absolute viscosity of the polymer. Next, reduced viscosity. What is reduced viscosity? It is very simple. Again, reduced viscosity is equal to specific viscosity per unit concentration. Specific viscosity per unit concentration. That is divided by C. C is mass concentration of the polymer solution. Gram per cc or gram per 100 ml, etc. Mass per centimeter. Mass by volume. Okay. So it is the reduced viscosity is defined as the specific viscosity per unit concentration. Specific viscosity per unit concentration. Okay. Now intrinsic viscosity. It is represented by eta within square bracket. It is very important. It is nothing but it is equal to the reduced intrinsic viscosity is equal to reduced viscosity only when the concentration becomes zero. When the concentration keep on diluting, the concentration tends to zero. Limit, this is also called limiting viscosity. Reduced viscosity is also called limiting viscosity. So, intrinsic viscosity is equal to limiting viscosity when the concentration becomes zero. Therefore, the eta is the divided by C. C tends to zero. The limit C tends to zero. It depends upon the intrinsic viscosity is very important. It depends on the polymer, nature of polymer and its molecular weight. It gives a measure of polymer contribution to the viscosity of the solution. What is the contribution of polymer, dissolved polymer, to the viscosity of the whole solution? Okay. Now, the intrinsic viscosity is related to molar mass. Is directly proportional to molar mass to the power A. Okay. Therefore, where K is proportionality constant, this relationship, this equation called Mark-Houwink equation which gives a relationship between the intrinsic viscosity and the molar mass of the polymer. Okay. But K and A are constants for a specific polymer. This was asked in CSIR 2016. Okay. Now, let us plot, for example, on plotting reduced viscosity versus concentration. A straight line plot is obtained. Okay. This is new reduced viscosity versus concentration. A straight line plot is obtained. Now, when the straight line is extrapolated, so that it meets the y-axis, the intercept, that is, this is again reduced viscosity, and the concentration is C tends to 0. Therefore, this is equal to your intrinsic viscosity of the polymer, given polymer solution. Okay. Now, this is known. Let us substitute here. On substituting this intrinsic viscosity here, the molar mass can be calculated by using this Mark-Houwink equation. Okay. But K and A are constants, are known. Now, the molar mass obtained by this method, is called viscosity average molar mass of polymer. Viscosity average. This value lies between number average and weight average molar masses of polymers. Okay. This was asked in GATE one time. So remember. Now, how K and A are determined? The constants are determined. It is very simple. Let us take logarithm of equation 1. Let us take logarithm. Actual logarithm, intrinsic viscosity equal to ln K, A ln M. Okay. Power will come here, A ln M. On plotting, this is a straight line equation. This is not a straight line equation. Now this becomes a straight line equation. Therefore, ln K, ln eta versus ln M gives a straight line. Now, ln M is for known molar mass. Okay. At different time point, you can break the polymer formation. If you take long time, if you give long time, the molecular mass will be large. Therefore, at every stage, you isolate the molar mass, particular molar mass of the polymer. Okay. Now you know for known molar mass, you plot for known molar mass, you measure the reduced viscosity, that is intrinsic viscosity versus ln M. The intercept gives ln K. The value of K is calculated from ln K, and from the slope, the value of the constant A value is obtained. Therefore, this method is very used in polymer industry and pharmaceutical industry, etc. Thank you for watching.